Okay, welcome back to Lesson 9. This is the last of chain rule and higher order derivatives. So how we're going to work these are we're going to use the other notation for chain rule. So what we have here is we have that okay, I know what the problem is. I have to resync my pen. I had to reboot my iPad because the last video did not take the sound. So we have dy dx equals dx dy dt dy dt times dt dx. But notice that x is a function of t, not t as a function of x. So what that means is that we need to take x equal to 2 plus 3t and solve for t. So solve for t. You cannot assume that dt dx equals 1 over dx dt. All right? That only happens in very particular cases of our functions. All right? So what you need to do is take x and solve for t. So x minus 2 equals 3t. Now I like to multiply both sides by 1/3 so that I get x 1/3 x minus 2/3 equals t. That way, when I find dt dx, I get that the derivative is 1/3. All right? Then if I have, so we cannot do this, then if I find dy dt, right, I know that y equals negative 5t, I find that dy dt is negative 5. So now knowing all of that information, I can find that dy dx equals dy dt times dt dx, which is negative 5 times 1/3. So that equals negative 5/3, which is pretty simple. All right? Now for number 17. What I'm going to do first is I'm going to rewrite y. So y equals x to the 1/2 plus x to the negative 1/2. Now I'm going to take what I want to do, what my directions are supposed to say, are to find dy dx when x equals 9 and t equals 1. Sorry, not dy dx, dy dt. So dy dt equals dy dx times dx dt. All right? Because remember, y is a function of x, but x is a function of t. So x is a function of t. All right, so if I take the derivative, so dy dt equals 1/2 x to the negative 1/2 times dx dt plus negative 1/2 x to the negative 3/2 dx dt. And the reason I put dx dt is because x is a function of t. So the derivative of x with respect to t is dx dt. All right, so now I'm going to put in x is 9 and t is 1. All right, so now I'm going to evaluate this. So I'm going to find dy dt when x equals 9 and t equals 1. So that is 1/2 times 1 over the square root of 9 times dx dt at 1, and that was -8, because it told me that, so it told me up here that dx dt of 1 is -8, right? Right here it tells me dx dt of 1 is -8, and that x is 9, all right? And so then I have minus 1/2 times 1 over the square root of 9, and I'm going to cube that, so that's going to be cubed, times -8. All right, so now let's scroll down so we can simplify. So this equals, the 1/2 goes into here and leaves a -4, and so I have 1/3 times -4. The minus and a minus make a plus, plus this is 1/3 cubed, so 1 over 3 cubed, times, and these go away and make a 4, because I've already gotten rid of the negative. So this equals -4/3 plus 4 over 27. Okay, so this is dy dt at x equals 9 and t equals 1. Is what both of these are equal to, since I wrote it right in the middle. So then dy dt at x equals to 9 and t equals to 1 equals -36 over 27 plus 4 over 27, which equals -32 over 27. Okay? All right? Now let's look here. This right here means to find the second derivative. So that is the derivative of the first derivative. And I am missing a page in my notes where I've written these up. Okay? So we're winging it. All right. So dv dr equals the first derivative. So that's going to be 9/8 pi times, r is a function of t, so I'm going to have 8r to the 7th dr dt. Okay? So now let's simplify that. So the 8's cancel, so that's 9 pi r to the 7th dr dt. Okay? Now, to find the second derivative, this is a product rule. So that is fg prime equals f prime g plus fg prime, where f equals 9 pi r to the 7th. So then f prime equals 9 pi, equals 63 pi r to the 6th dr dt, and g equals dr dt. So then g prime equals the second derivative, and we write that as d squared r over dt squared. So this right here means second derivative. All right? So now I'm going to scroll down just a little bit. So that means that to find the second derivative of the volume with respect to the radius equals 63 pi r to the 6th dr dt times g, which is dr dt, plus f, which is 9 pi r to the 7th times d squared r over dt squared. So let's simplify this. So that's dv over dr squared equals 63 pi r to the 6th. Now, these two multiplied together give us the first derivative squared. So that is not the same thing as saying, so this is the first derivative, so that's the first derivative times the first derivative, plus 9 pi r to the 7th d squared r over dt squared. And this is the second derivative. So that is the derivative of the first derivative. Okay? So here we're multiplying the first derivative times itself. Here we're multiplying taking the derivative of the first derivative. Okay? Now, from here on out, what we're going to be doing is we're going to be finding the second derivative, the third derivative, the fourth derivative, and so forth. All right? So for this one, the first thing we need to do is we need to rewrite the original function. So this is going to be x plus 2 to the 1/2 plus x to the 1/2 all raised to the 5th. All right? So when I find the first derivative, I'm going to use the chain rule. So that's going to be 5 times x plus 2 to the 1/2 plus x to the 1/2 to the 4th times the derivative of the inside, which is 1/2 times x plus 2 to the negative 1/2 times 1 plus 1/2 x to the negative 1/2. All right? So that's the first derivative. Now, I don't have to write this one, and I won't when I do the next part. So now, to take this derivative, I have to use the product rule. So that's going to be f g prime. So that's f prime g plus f g prime, where f equals 5 times x plus 2 to the 1/2 plus x to the 1/2 all to the 4th power. So then f prime equals 20 times x plus 2 to the 1/2 plus x to the 1/2 raised to the 3rd times the derivative of that, which is 1/2 x plus 2 to the negative 1/2 times the 1 plus 1/2, hold on, I'm out of room, plus 1/2 x to the negative 1/2. All right, times g, where g is the second parentheses, so g is 1/2 x plus 2 to the negative 1/2 plus 1/2 x to the negative 1/2, and I want to find g prime, which is negative 1/4 x plus 2 to the negative 3/2 minus 1/4 x to the negative 3/2. All right, so now I find f double prime. So that is f prime, so that's this. So that's 20, parentheses, x plus 2 to the 1/2 plus x to the 1/2 raised to the third times, notice that this thing is here and here, so I have two of them. So I'm going to square it. Squared. Now times, so that's f prime times g, that's done, plus f to the fourth times g prime. There we go. And so this is what your answer is. I do not want you to simplify. Okay? I want you to leave your answer just like that. Okay? Please do not try to simplify this. Okay? Now, we're going to try to find the fourth derivative. So the first is going to be f prime of x is minus 12x to the fifth plus 15x to the fourth plus 12x cubed minus 1. Oh, that was easy. F prime of x, so this is the second, is going to be minus 60x to the fourth plus 60x cubed plus 36x squared. Oh, that was easy. Third, oh, let's hope we're so easy. 3 ticks, x minus 240x cubed plus 180x squared plus 72x. Oh, good, we're still doing good. Fourth, f, and we write this as parentheses, fourth x equals minus 720x squared plus 360x plus 72. Phew! Those were easy. This should have been, no, 720 is right. I need to correct it on my sheet. Alrighty. Now, let's go to the last one. Alright, so the first thing we need to do here is we need to rewrite this as 4x minus 3x squared to the negative 1. So now we need to find g prime of x. So that's chain rule. So minus 1 times 4x minus 3x squared to the negative 2 times 4 minus 6x. Now, here's the deal. I'm not going to simplify this. I'm going to leave it just like that. Okay? So when I take its derivative now, I'm going to use the product rule. All right? So that's f g prime equals f prime g plus f g prime, where f equals minus 1 times 4x minus 3x squared to the negative 2. So then f prime equals 2 4x minus 3x squared to the negative 3 times 4 minus 6x. G equals 4 minus 6x, and g prime equals minus 6. So now let's find g double prime of x. So that equals 2 times 4x minus 3x squared to the negative 3 times 4 minus 6x times 4 minus 6x plus negative 1 times 4x minus 3x squared to the negative 2 times negative 6. Now, I'm going to simplify this a little bit. G double prime of x. I'm going to multiply these two together, and I'm going to combine this negative 1 and this negative 6. So this equals 2 times 4x minus 3x squared to the negative 3 times 4 minus 6x squared plus 6 times 4x minus 3x squared to the negative 2. When I find the third derivative, so I'm going to save this and scroll up so that I have room. When I find the third derivative, this right here is going to be a product rule. So that's going to be fg prime equals f prime g plus fg prime. So f equals 2 times 4x minus 3x squared to the negative 3. So f prime to the negative 3. So f prime equals negative 6 times 4x minus 3x squared to the negative 4 times 4 minus 6x. And g equals 4 minus 6x squared, so g prime equals 2 times 4 minus 6x times negative 6. So that's the first one. This one is chain rule. So to take its derivative, you're going to have negative 12 times 4x minus 3x squared to the negative 3 times the 4 minus 6x. All right? So that's each piece. So now let's put it all together. So we have g triple prime of x equals, the product rule first, minus 6 times 4x minus 3x squared to the negative 4, I'm doing this, times 4 minus 6x times the 4 minus 6x squared for the g. So those two are done. So I'm done there. Plus the f. So I'm here. 2 times 4x minus 3x squared to the negative 3 times the g prime. So that's going to be 2 times 4 minus 6x times negative 6. Now I add on plus negative 12 times, so now I'm doing the chain rule, 4x minus 3x squared to the negative 3 times 4 minus 6x. I don't need to do a huge simplification, but let's add a few simple things. So g triple prime of x equals, I'm going to combine these two, and I'm going to combine this number with this number with this number. Okay? So I'm going to just do those few simple multiplications. So this minus 6 times 4x minus 3x squared to the negative 4 times 4 minus 6x cubed minus 24 times 4x minus 3x squared to the negative 3 times 4 minus 6x right, minus 12 times 4x minus 3x squared to the negative 3 times 4 minus 6x. And if you notice, I have the same term here and here. I could still go further and say g triple prime of x equals minus 6 times 4x minus 3x squared to the negative 4 times 4 minus 6x cubed minus 36 times 4x minus 3x squared to the negative 3 times 4 minus 6x. And that's only because these two terms are the same. I have a cube, and I have a 4x minus 6 and a 4x minus 6. And so that's the only reason I can combine those two terms, is because they're identical. All right, and so that would be the final answer that I could